Alright, so 4.4 talks about some more of the logarithm rules. It focuses on rules 2, 3, and 4, and 9. So it first says if you got log of multiplication, you can break it up into addition of the logs. If you get log of division, you can break it up into subtraction of the logs. And if you got log of some number raised to a power, you can bring that exponent out front. And then the other one is your change of base formula, which we saw in the last section. Okay, so first one, example 1, says log base 4 of 2 plus log base 4 of 32. Well, you can write addition of two logs as log of multiplication. And 2 times 32 is 64. And we know 64 is 4 cubed. So these two match, so our answer is just the exponent. Now here you've got subtraction, so you're going to write it as division. And 80 divided by 5 is 16. And you want to write that 16 in terms of your base, 2. So we write it as 2 to the 4th, and now we know our answer is just 4. Now here you've got negative 1/3 log 1,000, and this is base 10, so you want to write the 1,000 in terms of 10. So log 1,000 is 10 to the 3rd. And this part is just 3, because log base 10 of 10 raised to the 3 equals the exponent 3. 3 times the negative 1/3 in the front is just negative 1. Alright, now here they want you to be able to break up these logs, and then the next example will ask you to bring logs together. So log of 6 times x becomes log of 6 plus log of x. Log of x cubed y to the 6th equals log of x cubed plus log of y to the 6th. And then you can also bring the exponent out front. Now ln of ab over cube root of c is ln of a plus ln of b, subtract ln of c. So the a and the b, ln of ab is subtracting, you get ln of ab subtract ln of cube root of c. And then the ab breaks up into ln of a plus ln of b. And the ln of c is the cube root, and you can bring the 1/3 out front. Now here we're going in the other direction, so you raise the 3, bring the 3 into the exponent, the 1/2 into the exponent. It's really the square root. And now you're able to use rule 2. You cannot use rule 2 and 3 if you have numbers in front of each of these logs. You've got to put those into the exponent before you can bring these together. So now that you've got log plus log, you can write them as multiplication, and 1/2 power is the same thing as square root. Okay, so here you bring the 3 into the exponent, the 1/2 in the exponent, and the minus 4 into the exponent. And so you've got all three of these guys, and now you can bring them all together with multiplication. Okay, s to the 3rd, t to the 1/2, t squared plus 1 to the negative 4. And now anything that has a negative exponent, you bring it across the fraction bar and write it in the denominator. And there's your answer. Now remember, we said log of multiplication equals the addition of the logs. We did not say log of x plus y equals log of x plus log of y. That is not true. And log 6 over log 2 does not equal log 6 over 2. No. Here's our change of base formula. Remember, the number that goes here is up top, the number that is your base goes on the bottom, and you pick a new base. So either pick 10 or e. So you can write log base 8 of 5 as log 5 over log 8, and just ask your calculator. Now when you type this in, you type in log and then 5, and then you have to close that with a parentheses. It's the parentheses, it's right above the 9. Then you hit the division key, then log, type in the 8, and then you have to close it with a parentheses. If you don't have that closing parentheses after each of these logs, you're going to get the wrong answer. Now here I've done change of base using both bases, and you notice you get the exact same answer. So log base 9 of 20 is ln of 20 over ln of 9, gives you that. Or log 20 over log 9, gives you the same answer. It doesn't matter which base you use, 10 or e. So, the log of a product of two numbers is the same as the sum of the logarithms of these numbers. So log of multiplication equals addition of logs. And now, log base 5 of 25 is log base 5 of 5 squared. Log base 5 of 125 is log base 5 of 5 cubed. So that guy reduces to a 2, that guy reduces to a 3, so the answer to this guy is just 5. The log of a quotient of two numbers is the same thing as the difference of the logs. So log of division equals subtraction of logs. And now, like before, 5 to the log base 5 of 25 is log base 5 of 5 squared. Log base 5 of 125 is log base 5 of 5 cubed. This becomes a 2, that becomes a 3, and you subtract and you get an answer of -1. The logarithm of a number raised to a power is the same as the power times the logarithm of that number. So in other words, log base 5 of 25 to the 10, you can bring that 10 out front, and in this part hopefully will simplify. It doesn't always, but this case it does. 25 is 5 squared. Since those two match, the answer for this portion is just 2, and you still have the times 10 out in front, so your answer is 20. So we can expand log x squared y over z to get log x squared plus log y minus log z. This top part divided by the bottom means you got the top, log of the top minus log of the bottom. And then the top being multiplied, you can break each part up into addition. And then finally you can bring the 2 out front, and you get as expanded as you can possibly get. Alright, so this one's log base 7 of 12. They're asking you to use change of base, so you write log 12 over log 7. I could have just as easily did base e, ln of 12 over ln of 7, and I get the exact same answer. And this one says, does log of addition equal log of a plus log of b? No. Does log of multiplication equal log of a plus log of b? Yes. Log of multiplication equals addition of the logs. That's true. Now here they're asking you to figure out what this is. Well, if you bring these together, write the subtraction as division, you get 4. And 4 you can write as 2 squared. And since those two match, the answer is just the exponent 2. Log base 5 of 1 over 25 is log base 5 of 1 over 5 cubed. When you cross the fraction bar with that 5 cubed, it becomes 5 to the -3. And now those two match, so the answer is just the exponent. Log base 6 of 9 plus log base 6 of 24, well that's log base 6 of 9 times 24, which is 216. And 216 is 6 cubed. And now these two numbers match, so your answer is just the exponent, 3. Log base 4 of 16 to the 100, you can bring the 100 out front. And you can write 16 as 4 squared. And so since those two match, the answer for this portion is just 2. And it's 2 times 100, gives you 200. Here they want you to break this up, so you write this as log base 6 of 7 plus log base 6 of r. Log of multiplication becomes addition of logs. Now here, they ask you to do this one. Well, if you figure out what's on the inside first, log base e of e to some exponent, in this case your exponent is that one right there. Log base e of e to an exponent equals the exponent, so that inside reduces down to just e to the 200. And now you got log base e of e to the 200, so your answer is just the exponent, 200. ln of log base 3 of 9 to the 50th equals log base 3 of 3 squared to the 50th. And the 2 and the 50 multiply to give you 100. And so now these two match, so your answer is just the exponent. Here they're asking you to break this up, so you got log base a of x squared divided by yz cubed, so that becomes subtraction of the numerator and the denominator. This 2 comes out front. Now this part is going to break up into addition because it's multiplication, but you got to be careful with the negative that's out front. You got to distribute that negative sign carefully. So you break this up into addition, and then you hit each one with that negative sign. And then finally you can bring the 3 out front because it's in the exponent. Alright, ln of y squared square root of x is ln of y squared plus ln of square root of x. You can bring the 2 out front, and you can write that with a 1/2 power, and you can bring that out front. Alright, now this one is log of square root of x plus z over y, so each part, the top and the bottom, are raised to the 1/2 power. That's the same thing as the square root. You can break this division up into subtraction, and then you can bring the 1/2s out front. And that's as far as you can go with that one. This one, log of division becomes subtraction. Okay? And now this one you can break up into, you got 4 times x squared, so you break it up into 4 and x squared. And you can bring the 2 out front. You can't do anything with the 4. You can't bring that 2 out front because you got to add 3 there. That doesn't allow you to do that. Alright, so here you get 1/2 times all of this stuff. You can do 1/2 times each one. You can bring the 1/2 into the exponent for each one, and this one being subtraction, I bring a negative 1/2 and a negative 1/2. Okay, and now all of these are being added so they can all be multiplied. Log of multiplication. And now each one with a negative exponent crosses the fraction bar and is now in the denominator. And each one of these 1/2s is really the square root. So your final answer it looks like this. Okay, now this one you want to multiply each one by a 4. Now you want to put each one of these numbers that are in front into the exponent, including the negative 12. And now you bring all these guys together because you're adding them. You can write them as one multiplication. And now you cross the fraction bar with that negative 12 becomes positive 12 in the denominator. And that's as far as you can go with that. With this one, you got 1/3 log of this plus 1/2 times that, 1/2 times that. You can bring each one of these numbers into the exponent, including the minus 1/2. Well, 3rd power times 1/3 power gives you just 1. 1/2 and 4th power, when you multiply 1/2 times 4, you get 2. And a minus 1/2 times a positive 2 gives you a negative 1. And so now each one of these is going to come together, but eventually you're going to take that one and cross the fraction bar and make it to a positive 1. So everything is multiplied. You can write all these things together multiplied, and then you realize that that minus 1 is going to cross the fraction bar, making it a positive 1 exponent. Alright, so these last two, they're asking you to do change of base formula, so you get log 10 over log 5, and you can figure out what that is. Log base 9 of 4 is ln of 4 over ln of 9. I could have used log as well. This one is log 2.5 over log 12. And remember, when you type these in, you hit log 2.5 close parentheses, divide, and then log 12 close parentheses.